Hi ladies and gentlemen, welcome back to my channel. Today we're going to look at inductor designs for resonant circuit. So this video we showed yesterday on wireless microphone, we use an inductor that is homemade, and we want to show you today how to make such inductors. Now, inductance L is calculated using the formula that I'm showing on the screen right now, where the L is inductance and D is the diameter of the coil. We're going to show you how to get that. D squared multiplied by N squared, which is the number of turns, divided by 18D. Again, this D is the diameter of the coil, plus 40L. Right. The L is the length of the magnetic circuit. So length of magnetic circuit. Right. So this is the length of the magnetic circuit, and we're going to explain everything so it's easier to understand and to follow. First of all, the first parameter we want to describe here is the diameter. So let's say I make a coil on any cylindrical object. So let's say I take a pencil or any other object of known diameter. Let's say the diameter of this object is 5 millimeters. Alright, so let's just write it proper. It's 5 millimeters. Or let's say it's around the one we did yesterday was around 0.0245 inches, something like that. This, all right, 0.0245 inch. Now when we take this material and then we put coil around it, right, such that if my coil is wound, if you're looking into the coil, you will get something like this spiral, because they are on each other. You really don't know the number of turns from this way, nor the length of the coil. But let's say you're looking into this coil this way, so going in one direction and then on the other side of the coil, so you just have something like this. So if I have an arrow going this way, the end of the arrow will look something like this. So the tip, the pointed side, will be here, and then the opposite end of it will be this, looking like a plus sign. So I'm looking into the coil this way, and out from the other side of the coil will be that. So one of them will be north pole, one of them will be south pole if I apply current through it. Now this is the diameter of that coil. Now I'm going to make it a little bit bigger to explain this better. So assume this is that. We couldn't draw a very good circle, so let's try to fix it. So just assume this is a circle, right? And this has a certain diameter. We're gonna call it X. I know it's diameter, but we're gonna call it X for this object. And then I have a coil on it. Let's say this is 1 turn. So that means this coil or the wire has a certain width. This has a certain width to it. So this is the width of the coil, right? Or so if you're taking the cross-sectional area of the coil, take the wire, you take a wire this way, and then the cross-section of that wire, the width of this wire, that's what we're calling W. Okay, so you're taking that, and if you want to know the width of this coil, then this must be a single turn coil, which means no wire goes above each other. They just go side by side by side by side until I get to the end of the coil, right? So there's a single turn coil. Now if you take the width of this wire and add it to the diameter or the X of the object you're using to form this coil, that will give you the D. So really our D in this calculation is this. So the width of the object we're forming the coil on plus the width of the wire. That gives us the D. Another way to look at it is you can take half of the wire. So I'm going to make this a little bigger. I'm going to change the color. Let's take a different color. If I take half of this, half of the width, remember this is just one wire width. So I'm taking half of this and I'm joining it to half of that. Right. So then the D will be this way. And that will be my D. Right. Another way to take my D also is to look at it from let's take a different color this time. We can take the D as from here, from this point to that point. That's also another way of finding our D. So in the video tutorial we did yesterday, we say that there are 3 possible D's. So let's look at that. So this will be it. That we want from the half of the coil to half of the coil, including the X, which is the former on which our coil was made. That gives us the D. Or you can take from the outer to the inner. So outer of the coil plus the X, that is your D. Or you can take from the inner to the outer. That gives us your D as well. So however you want to do it, that's how you get your D. And then when you get your D, the number of turns is based on just actual physical turning. So you turn it, and I can tell you that the minimum length of this coil, the minimum L, so this L here, L minimum will be, here we estimated that the width of the wire is W. So the minimum length will be L minimum will be equal to or equivalent to, let's just say equivalent to W, which is the width of one wire, multiplied by N, which is the number of turns. Because really, if they are tightly packed together, if the wires are tightly packed together, then it would, the length of the magnetic circuit will be that wire plus the next wire plus the next width plus the next width plus the next width, and since it is the same wire, the width will just be a multiple. So multiply by the number of turns, that will give you the length. That's the minimum length. Of course, you can space it out a little bit to change the inductance. So 2 things are easy to identify here. One of them is the diameter, the other one is the number of turns, and then L will vary on how tightly packed the wires are. L will vary on how tightly packed the wires are. But I want you to see something here. My L, the capital L, not the small l, but my capital L is a function of dn and L. dn and L, right? 18 and 40 are all constants. So my L, my inductance, is a function of the diameter of the magnetic circuit, the number of turns, and the length of the magnetic circuit. So if I am shooting for a particular L, let's say I'm looking for 0.1 of whatever unit. If I'm looking for 0.1 of that unit, I can choose the diameter of the coil easily because I would have my wire. And then this will help me determine N and L. So I'll give you an example. I'm looking for 0.1 of a particular unit. I don't know the unit right now. Then I know that this will be D squared multiplied by N squared divided by 18D plus 40L, small l. So what I'm going to do is I'll take the wire because I will have the wire already in my hands. I'll take the wire and I measure the W of that wire. I measure the W of that wire. And then I'll determine the circumference of the object that I want to make the coil out of. So that X plus my W will give me my D. So I can plug in my D here right away. So I have D now. And on the denominator as well, I have the value for D also. And then my N and my L will be determined by the number of turns that I put in there, right? So I have everything I need here except N and L, N and small l. So I can start to play around with this. I can have 2 turns here. If I have 2 turns, so this will be 2, then L will be 2 times W. So I can do this and see if I'm close to this value, and so on and so forth. So with a little bit of trial, you'll be able to get to where you're going to. Now, this XX, we know what the value is, to be frank, because we know the unit. Let's look at the units. So when you use this formula we have here, your unit for L is in microhenry, unit for D and L, small l, is in inches. That means if I have my D and N and L, basically if I have my D and N, I know my L, minimum L, because you can actually stretch it to be more, but I'm talking about the minimum value. Now, if I know these values, whatever I calculate, the value that I get is in microhenry. So if I get 0.1, for instance, as the answer, it's not just the answer. I have to add microhenry to it. If you're using this unit in inches and this in inches, invariably, whatever value you get at the end is in microhenry. So when you do this, you will get the inductance of your circuit. Now, what we did yesterday in that video tutorial was we just made a coil of 5 turns. We made 5 turns. We made 5 turns, that so N is equal to 5, and L is easy to calculate. Minimum L, we know it is 5 times 0.0245. That's our minimum L. And then we know that, so we just plug it in. This squared, we already know our D squared because we know the width of the object we're making the coil out of. We know the width of our wire, and we just get our D from there. So we say that L is D, we know, D squared, N we know, N squared, 18D, we know the value there, plus 40L, we already know the value there. When we calculated, we got a value of about 0.1117 microhenry, something like that, approximately 0.12 microhenry. So when we got this, we wanted to make sure that the resonant circuit for our transmitter is built around certain frequency. So resonant frequency, or your fundamental frequency F0, is equal to 1 over 2 pi, or you can just say omega, but 2 pi square root of LC. Now, we know the FO. FO is actually a range from 88 to 108, because we're building this for FM transmitter. And then we know L from our calculation. The capital L from our calculation is about 0.12 microhenry, yeah? And then we just need our C. C was unknown. So F was known. Okay, I'm gonna change something a little bit here. Let's just move these values around. Okay, let's move this. Okay, good. So FO is equal to that. Yeah. Now, for us to calculate C, we just plug in the values, right? So when we plugged in a value of 88 megahertz, so I have 88 megahertz, 88 megahertz is equal to 1 over 2 pi square root of LC. We get a C of approximately 27.6 or thereabout picofarads. And we have a ready-made value of 27 picofarads capacitor. So we use the 27 picofarads picofarad capacitor in our design, and we were able to play around with the inductor to just change the value of the frequency to get us in the FM range. And immediately after building this without any adjustment, with the value that we have from the inductor and the capacitor, including the tolerance, of course, of the capacitor, we were able to operate around approximately 104 megahertz without any adjustment. Just turning the transmitter on puts us around 104 megahertz. Then we played around with the coil a little bit to get us into the range that we want. So let's recap. If you want to build a transmitter of any kind, you need a resonant circuit. Very important. The resonant circuit that you need will, okay, let's draw a resonant circuit first. So there are parallel and series resonance. So yesterday we built our system based on parallel resonance. Just means inductor and capacitor in parallel. Of course, it goes without saying, series resonance then is this way. But we're going to concentrate on parallel resonance today. So this is what we built yesterday. And because this value was fixed, the C was fixed. All right, so let's make it a little bit smaller. Yeah, because our C was fixed, the only variable component for us was the L, and we're able to change the value of L by changing the length of magnetic circuit. The circumference or the diameter was fixed in a way, in a sense. The number of turns also fixed in a sense after making the coil. The only thing we can change easily without disrupting so much was the length of the magnetic circuit, which means the length from here to this point. So we can drag out this coil, make it space out, so the how packed they were, we could change that. So we could make it look that way, or we could make it look more loosely packed together, so that we could change. And that you've seen from the equation that the L, the length of the magnetic circuit, has a role to play in inductance. You know, what you can see from the formula actually is that capital L varies inversely with small l. So let's write under equation. Anything that is under is an inverse, has an inverse relationship. So I'm gonna try to write it out in another page, in another place. So what I'm saying here is that L varies inversely with L. So normally when you build a circuit, normally when you build an FM transmitter or a transmitter, people will tell you make your number of turns to be 5. They say 4T, 4 to 5T. That's what you hear. Or sometimes they say make it 8T, something like that. And then they will tell you the size of wire. So let's say they give you the SWG or AWG, the American wire gauge or the standard wire gauge of the wire. And they will tell you number of turns to make. And that's all they tell you. But what you're actually doing in doing that is you're making an inductor of a particular inductance. So you know your L, then you know the D, because they've given you the D. Invariably, they told you to make it around 5 millimeter piece of maybe drill bit. So you have a drill bit of 5 millimeters, and they're telling you the AWG or SWG of the wire. So that will be the W on top of this. So basically, your D is already determined from here. And then they're telling you to make it 8 turns. So they're already telling you the N. And then 18D, this is already known, plus 40L. Minimum you're going to get here will be, minimum for L will be W, which is the width of the wire, times number of turns. So your L here will be something like will be N times W. Basically, they've given you all this. So if you know this, you can determine the inductance of the coil that you have just made. And then just throw it into your resonance circuit, and you have made your inductor and you have made your circuit. All right, so that's where we're going to end it today. So I hope you've learned something. So when you're building a transmitter or a receiver and people are telling you use this number of turns, I want you to know that you can actually determine the inductance of that circuit. You can determine the inductance of what you have just made, not just because people told you T number of turns, let's make this bigger, number of turns is 8, and in our case we call it N, right? Number of turns, T or N, is 8, and then they're telling you the diameter of the former to make it on. They say it is 5 millimeters, and basically that's what they give you. So, and then also they give you the wire gauge. So they'll give you S or AWG of the wire. They might tell you say 22 SWG or something like that, or AWG. So with this, they're already giving you the spec for your inductance, and what I'm trying to give you now is the knowledge behind this you are being told to do. And the knowledge behind that is that they want you to get an inductance of a certain value. If you can plug this into the formula, which we'll be showing all along, I'm going to show you one more time before we call it a day here. If you plug it in into this formula, L is equal to, which is inductance, is equal to D squared multiplied by N squared divided by 18D plus 40L, and the units here is in micro Henry. The units here is in inches. This is just number of turns, so no unit. And then the length also is in inches. D, of course, we already said D, but let's just say it again. When you know all this, you're able to calculate the inductance of your circuit. All right, we're gonna see you again next time. Please remember to subscribe, like this video, share with your friends. What we give you here is not just a quick video. We're not just here to show you one quick tutorial or something I've done. We want you to actually have knowledge behind the tutorials you're watching on other channels and also on our channel. Sometimes we do quick videos, but sometimes we want to teach, we want to show the underlying principles behind some of the things that you see on our channels or other channels. All right, I must see you in the next one. Until then, remain enthused.